Before we jump into lighting in the GafferThree node, let's handle some scene management to set up our render settings. In our scene, we'll require a camera for rendering. Maybe even multiple cameras if you would like to arrange various camera angles to fully view a set, for example. So, we'll start by adding a CameraCreate node and adjust it briefly, just to suit our current framing needs. The CameraCreate node is used to create a scene graph location containing a camera. The CameraCreate node does not load the camera from any file or asset, but instead builds an entirely new camera from the parameters you specify on this node. We can start by setting the field of view to 35. 35 is a good average for capturing everything at the human eye level. Then, I'll merge this camera into the scene using a merge node. To do this, easy peasy, simply select both relevant nodes and hit the M key. We can raise the camera y-axis a bit, so it is not sitting on the ground. About 1.5 units seems okay. We will also slightly adjust the zoom and position of our camera. The center of interest will be offset, but it won't cause any issues. We will also need a render settings node to first set our render camera path, which will be the camera we have just created, our renderer, which will be Arnold, our resolution, which will be HD, 1920 by 1080. Then we can also add adjust height to match resolution, to adjust the height of the screen to match our output resolution. We will also need a normal global settings node to adjust a few more things. I like to select Allow Untiled Textures, Texture Auto Generate TX, and Texture Auto TX Path, even though it is highly recommended to use Make TX first, instead of trying to bypass errors arising from improperly setting up texture files. In the case of a texture map file not being natively mapped, the render will give an error unless Allow Untiled Texture is checked. I've found these options to be helpful in avoiding errors during render times, especially with some HDRI texture files. This node also contains other features that could be disabled at render time if you would like a quick shortcut to resolving some issues. Once we are happy with our settings, we can select all our nodes and press G to neatly group them. Renaming is a habit worth adopting, so let's rename the group as Camera Scene Settings. Alright, it is now time to dive into some creative aspects of our template by comparing our asset under different lighting scenarios. Our materials are still waiting to be imported and assigned to Emis. Emis is still a great asset, lurking in the shadows of Katana. Well, let's fix this. We'll be switching things up a bit by starting with the lighting instead of the materials. Why, you might ask? The goal is to have those lighting scenes ready to go when it's showtime for our shaded character. Imagine the anticipation. For showcasing Emis, we have 3 classic lighting setups that studios often use, which are a cloudy mood, a sunny sky, and the cozy vibes of an interior set. To make the magic happen, we'll be creating a GafferThree node for each input. Let's light things up. In the first GafferThree node, we will right-click and add an Arnold HDRI Sky Dome light. Under Material in the Arnold Light shader, we can play with the exposure and the intensity of the Sky Dome, and we can also rename the AOV if we would like to render this light separately. Under the Arnold Surface shader, we can right-click on the file name and add an expression to call our HDRI texture file path. I can now copy-paste this node twice and change the texture file path in each Sky Dome. We can now add a variable switch node. The variable switch node takes the value of the graph state variable as input and uses it to determine which input port to activate. In other words, each input port of the variable switch node corresponds to a different configuration or setup that you want to switch between. It is now time to connect the dots and unleash the true power of Katana. We will grab our variable switch node and lock it into our project settings. And this is where the real fun begins. A naming convention is a must. A mismatch here means no connection there. And we truly want a connection there. Now, let's scroll down to the Project Settings tab, find the Variable section, and there it is, the Graph State Variables. Give it a click and add variables. Now, pressing the wrench icon, let's sync it with the variable name of the variable switch. Patterns are up next. Just type them again into the empty menu area and hit enter. Now, watch those patterns pop up at the very top of our interface. Just one final step remains to complete the section of our template. Enabling our HDRI lights to undergo a 360-degree rotation for the last 50 frames of our scene. We'll achieve this by creating a Transform 3D node, dragging the path from the top of the hierarchy for all the lights in our scene graph, and adding a simple expression to the y-axis of our Transform node. If our frame is greater than 50, but less than 100, a rotation of 360 degrees will happen. Otherwise, it will remain as is. Voila! Now this dynamic lighting touch is smoothly integrated into your template for good. To summarize this second video, we created a render camera for our scene, we merged it into the main tree, we added a render settings node where we set up our resolution, renderer, and camera path. We added a normal global settings node to prevent render failing. We group all these nodes together. We set up 3 different lighting scenarios with 3 different GafferThree nodes. We connected all these inputs into a variable switch, which populated our various lighting variations to the graph state variables in the project settings. And we added a Transform 3D node to set up a light rotation for the last 50 frames of our template. Bravo!